Course 3, Lesson 41, we are looking at functions, what makes something a function, and also decide what makes a graph proportional. So a couple of vocabulary terms here. A function is a relationship that has exactly one output for each input. So if I plug in a value, I get one and only one output. Our domain, that's the input of the function, so our x values. And our range is the output of the function, or the y values. So to make something a function, what we are saying is if I have an x value of 1, that, if I plug it into my example, let's say my equation is y equals x plus 4. Oh, let's see if I can write it. This board is giving me some troubles today, that's okay. So if I have an equation of y equals x plus 4, that means if I plug in 1, I'm going to get 5. And if I plug in 2, I'm going to get 6. If I plug in 3, I'll get 7. Plug in 4, and I get 8. Now, it wouldn't make a lot of sense if I plugged in 1 to this equation and got 2 different answers. So, a function tells us that if I plug in an x value, I will get one and only one y value. Now, you might be asking, what would it look like to not have a function then? And I would say, well, there are some examples of functions, especially things like circles or parabolas that have been put on their side. But in a map like this, we would say, what if 4 not only went to 8, but also went to 7? Somehow we had an equation that gave us that answer, that we would have 4 going to 2 different numbers. That would not be a function. So in this example, we have 5, 6, 7, and 8. 5 goes to 7, 6 goes to 10, 7 goes to 13, 8 goes to 16. And we would say, is this a function? And the answer would be yes. Okay, we have a function here because every single one of these x's goes to 1 and only one output. Now, what if I were to extend this table and add a few bits more of information? Let's say 9 goes to 19 and 6 goes to 15. Now let's say, okay, 9 goes to 19, good. And 6 goes to 15, but wait, I thought 6 went to 10 up here. So how could it now be going to 15? Well, with this additional information about this, I would say, well, this function, this is not, or this information, this is not a function, because that 6 goes to too many different things. All right? So let's look at this one. We have information about x and y, 1, 2, 3, and 4 goes to 3, 5, 7, and 9. So, is this a function? And if it, and then we're going to graph it and see if it's linear and if it's proportional. Now, proportional, remember, has two different things that it needs. It needs to go through the origin, and it needs to be linear. It needs to be a straight line. Okay? So, let's see here. Is it a function? Well, 1 goes to 3, 2 goes to 5, 3 to 7, 4 to 9. This is a function because every x value goes to 1 and only one y value. And let's graph it. So we have 1 up 3, 2, 5, 3, 7, 4, 9. And when we look at this, we would say, it is a line, this is linear, it goes up at a consistent rate, but no, this is not proportional, because even though it's linear, it does not go through the origin, so this is not proportional. Let's try another one. 0, 0, 1, 1, 2, 7, and 3, 9. Now I would say, yes, this is a function. We're good to go there. The question is it linear? Is it proportional? So 0, 0, 1, 1, 2, 7, and 3, 9. Now let's say this curve thingy, this is not linear. So, is it proportional? No. Although it goes through origin, 0, 0, it is not linear, so this is not proportional. Let's just try a couple others. So we have -1, -2. We have 3, 8. We have 5, -4, way down here, and 3, 4. Well, first of all, I look at this and say, is this a function? And we would say, no, because 3 here goes to 8, but also goes to 4. These two dots right here are on the same x value, but different y values. This is not a function. Is it linear? No. If we were to attach it to in order what we said, this is definitely not linear. Is it proportional then? No, it is not, because it's definitely not linear, does not go through the origin. All right, and let's do this last example. The area of a square is a function of a equals s squared. Describe the rule with words and make a table that shows at least 4 pairs of numbers that satisfy the function. So we already know it's a function. Then graph the pairs and predict the graph of other points on the function. Is it linear? Is it proportional? So we have this equation, a equals s squared. And let's say I plug in -2, -1, 0, 1, and we'll do a fifth one too. So I plug in -2 and say -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. The question is it a function? And it is. Every single x value that I have goes to 1 and only one y value. It doesn't matter if some of those y values are the same. That's fine. So let's graph it. And I'll start with my 0, 0, 1, 1, 2, 4, and my negative values as well. This is what we call a parabola, and it is a function. Is it linear? No, which means it's not proportional. We also know that it's a function based on something called the vertical line test, which means that if I take a vertical line at any point here, it should only cross at one point. So we take a couple of vertical lines, only one point does it cross. This is for sure a function. Well, I hope this is helpful for your homework and for studying.